Here's what I observed first, by the way, about elimination. I noticed that my X's are all lined up, my Y's are all lined up, my equal signs are all lined up, and my numbers are all lined up. That is a great indicator that elimination is the way to go. So while I'm going to erase those blue boxes, this is definitely something that I want to use. Now, as my strategy goes, I'll tend to look at two things, and if I don't find something that I want, I immediately start working in a different direction. The first thing that I look at is my X column. When looking at the X column, I'm trying to identify, do I have the same number in front of the X? In this case, I have a 4 and 3, so obviously not the same number. And if I don't have that, I immediately go to the second thing. I'm only looking for two things. I go to the Y's. Once again, I look for, do I have the same number? Now, I don't really worry about the positive or the negative piece. That'll come later. But I look for the number. Math teachers call these coefficients. I look for the numbers in front, and I look for, are they the same? And if they're the same, then I love it because life is so good. But, well, I don't have the same here. 4 and 3 in the first, 5 and 2, or 5 and -2 if you prefer in the second. So no good. So my two strategies are out. My first two things to look at are done. So here comes my strategy. I'm going to turn the 4 and the 3, the 4x and the 3x, I'm going to turn them into the same exact thing. So I start thinking about how to do that, and we get into least common multiples and this wormhole of arithmetic that you did a long time ago. Look, we're going to make this really, really simple. If you just do what I'm doing, life is easy. Watch this. I'm going to go ahead and take the 3 here, and I'm going to multiply the entire first equation by the 3. If this number right here was a 5, I would have multiplied the whole first equation by a 5. If it was a 7, I would have multiplied the whole first equation by a 7. Whatever that first number is what I multiply the first equation by. And you might already guess what we're going to do for the second one. We look at this number, and we put it here, and we multiply the bottom equation by the first number in the first equation. So I take the 4 from the first and multiply the second one. I take the 3 from the second one, multiply the first, and here's what I'm going to get. Lots of distributing later. I'm going to get 12x plus 15y equals 9, and now I'm going to do the bottom. I'm just going to do the arrows across the bottom so it's not confusing. 4 times 3, 4 times this, and 4 times this. So I get 12x, negative 8y, and 32. And look at that. Now I have perfect pairs. Cool. All I have to do now is subtract, and I'm practically done. So subtract them up, 12x minus 12x. I did this with a student the other day where I highlighted the thing that I was looking at, and then I just shifted that highlighting over so that they could see what we were doing. So I could have picked a bigger highlighter, but here we go. 12x take away 12x is 0x. I'm not even going to write it because the whole point is to eliminate. Next, I'm going to go ahead and move this over. 15y minus negative 8y, 15 minus negative 15 minus negative 15 plus 8. So 15 plus 8 is 23y. And now I'm going to move this over again. And I'm going to do 9 minus 32. 9 minus 32. So that's really just 32 minus 9 with a negative sign on it. 12, 3, 2. So 23 with a negative sign on it. And now I'm practically done. Divide both sides by 23. Y is negative 1. Don't miss that negative sign. Let's get rid of this mess here. And now I'm going to go ahead and take this negative 1, and I'm going to put it back into one of the two original equations. I think I'm going to put mine there. So 4x plus 5 ones is 3. So 4x plus 5 is 3. 4x is negative 2. And x is negative 1/2, right? So a little bit fancier with the fraction, but really it's just a fraction. Negative 1/2 comes first because x's come before y's, and negative 1 comes second, and I'm done. That's it, right? So 5 minutes and 20 seconds, and we're done with the first example. Let's launch into the second one. I'm going to do the same exact strategy. I'm going to look for the two things that I want. If I don't find them, I'm going to immediately work on that. It almost looks like cross multiplication from way back in arithmetic. It's not really cross multiplication, but it looks like it. So let's go ahead and take a look at the second one. I'm going to use my blue arrow like I did before, and I'm going to look for things that are the same. I see a 5 and a 1. Well, those aren't the same, so I move on. I see it. Oh, this is nice. When you see the 2 and 2, things are so good because you don't have to do that crazy multiplication piece in the beginning. So this is so nice. I see this right here. I also see that they're opposites. If they're opposites, we don't want to subtract them. We're going to add them up because we add opposites and they go away. So check this out. This is really nice. We're going to add these 2 equations up. Here's my highlighting, much bigger this time. And we're going to go ahead and say 5x plus 5x plus 1x, right? 1x is 6x. And 2y plus negative 2y is 0. 0y, I guess. So that goes away. That eliminates. Equal sign. Don't hate on your equal sign. And let's do one more. Oh, I keep grabbing something I don't need. There we go. And 17 plus 8. 17 plus 8 is 24. Divide both sides by 6. X is 4. And then you could probably see how we're going to finish this out. As far as finding the easier one, I think the second equation is probably the easier. So put the 4 in the x. So I get 4 minus 2y is 8. Minus 4 to both sides. Minus 2y is 4. Divide by negative 2. And I'm zipping along here because I don't want the video to go longer than it needs to. And I get 4 and negative 2. So look for those 2 things in the beginning. If you see common x's or common y's, life is good. If you don't see them, go ahead and cross multiply.